So this is the LeetCode 1642 question, furthest building you can reach. I just wanted to kind of go over this solution. Because if you look at the optimal solution, so the optimal way to do it is to use a heap. And so there's really only two ways to approach the problem. You either use ladders first, and then when you run out of ladders, you replace the gap that was the smallest with bricks until you run out of bricks. And then the other option is to start with bricks, and then when you run out of bricks, you replace the biggest gap with a ladder. And so I chose the ladder option, pun intended, and I just wanted to show that you can still do that using heaps. It just takes a little bit of tweaking because, as you know or should know, heaps work by having the smallest value in the first spot. And so when you use the method that I chose, you actually need the largest value in the first spot. And a simple way to do that is to just negate the values. So instead of adding like the height difference to the heap, you add the negative of the height difference to the heap. So we can just go through it really quick. So I just called gaps as my list, which is going to use Python's heap function. I just set n equal to the length of the heights. I checked for this just in case. I mean, because it's not hard to check for, but ladders allow you to scale the building regardless of its height. And so if for some reason you were given more ladders than buildings that you need to scale, then by default you can get to the end. And so anyway, that's kind of just I don't even know that they would check for that, but I just wanted to test for it because it's very simple to test for, and it can save a lot of iteration. Like just as an example, like if there was 100,000 buildings and you had 100,000 ladders, you wouldn't even need to go through that whole list. You would just know you can do it. Anyway, so I'm just starting at the so you can see I'm starting at 1, and so all I'm doing is checking to see if I can make it to the next one. And so if it fails, then like I would return I-1, meaning that the furthest building I reached was the one before the one I'm testing. But anyway, so I just checking to see if the next building is taller. If it is, I'm capturing the height difference in this height diff variable, and then I add it to the heap. I then subtract. So I'm starting with bricks. I then subtract the height difference from the bricks that I have. If I have less than 0, then I check to make sure I still have ladders left. Obviously, if I don't, then the furthest building I can get to is the previous one that I got to, I-1. If I do have ladders left, then I subtract one of the ladders, and then I'm replacing the ladder with the ladder that was used on the biggest gap. I'm replacing the, or sorry, I had that backwards. So if I have a ladder, I'm using one on the largest gap that I used bricks for, and so I'm adding those bricks back. But in this case, I have to subtract the bricks back because if you remember, in order to make the maximum number be at the start of a heap, you have to use the negation of it. And so like if it was like -5 as an example, I would need to add back the 5 bricks that I used, but it would be -5. And so if I added the -5, it would make it even further negative. And so you just have to subtract them back to get them back. That's the only trick you have to do to make heaps work for a maximum value. And so that's what I did. And then yeah, it works the same basically as the optimal solution that starts with ladders. It's just that solution you get to use the heap the way it functions by default. And so you can see here, memory wasn't great, but I mean it fluctuates a lot when I rerun it, but the speed was relatively good. So hopefully this helped if you're struggling on this one.